Good day, welcome to Memo's Tutorials. Today we are focusing on chemistry and we are going to be looking at matter. So we are introduced to an atom, which is the smallest unit of matter, and we are required to know the components of an atom. So an atom has got the nucleus. We have the nucleus in an atom, and inside of our nucleus we have got what we call neutrons and protons, right? Inside of our nucleus we have got neutrons and protons, and we have got shells on our atom, and these shells, they contain electrons, right? Electrons, we find them in shells. I'm sure you can see that these electrons, they are negatively charged, and then the neutrons, they are neutral, they don't have any charge, there's nothing in there. And the protons, they have a positive charge. So those are the properties of an atom. Let's have a look at them in detail. This table, you must know it very well. So when looking at an atom, you should know that it has got protons, it has got neutrons and electrons, and you should know the location. Where do we find the protons? In the nucleus. Where do we find the neutrons? In the nucleus. Where do we find the electrons? In the orbitals or in the shells, right? You are also required to know the charge. The charge of protons is positive. The charge of neutrons is neutral. Neutrons, neutral. Electrons, they are negatively charged. And then as for mass, the mass of a proton, it's 1, and the mass of a neutron is 1. And the mass of an electron, here we said it's 0, but some scholars, they believe it's 1 over 1840, meaning it's 1 over 1840, right? They are very, very light. Okay, so you are also required to know what we call Nuclide notation. You should know how elements are shown in a periodic table, right? So this blue capital letter X is to give us the abbreviation of the particular chemical formula or of the particular element. And then A is for the mass number, and you are required to know that mass number is the number of protons and the number of neutrons together. So the mass number is sometimes called the nucleon number. Nucleon number simply means the weight of our nucleus. What do we find inside the nucleus? Protons and neutrons, right? And we have what we call the atomic number, which is the number of protons. The atomic number, it's your proton number. And our very good example here, we are having a C. This C is for carbon. This is a chemical symbol for carbon, and 12 is the mass number of carbon, and 6 is the number of protons in a carbon. So there's something that I need you guys to know, is that the number of protons and the number of electrons are always the same in a neutral atom, right? The number of protons and neutrons, they are always the same. So this carbon molecule, this carbon has got 6 protons and 6 protons and 6 electrons all together. Okay, and in this case it also has got 6 neutrons. How did I get the number of neutrons? You simply say mass number minus proton number, you will get your neutron number, right? Let's have a look at the following examples. Like I have said, that the difference between proton number and the mass number gives us the number of neutrons for each element, right? So in other terms, we say number of neutrons, we simply say mass number minus your proton number. Remember, the proton number is the number, it's also called the atomic mass, right? For example, we've got oxygen. To find the number of neutrons in oxygen, you simply say its mass number, which is 16, minus 8, which is the proton number, you get 8 neutrons. Chlorine has got a mass number of 35, so you simply say 35 minus 17 protons, you get 18 neutrons. Same applies for calcium. Calcium has got a mass number of 40, and then the number of protons is 20. So 40 minus 20, you remain with 20 neutrons, right? So we then have what we call isotopes. These are atoms of the same element that have got different number of neutrons. The number of neutrons are not the same, but we have exactly the same number of protons, right? So isotopes of an element, they have the same proton number. The only difference is on nucleon numbers, right? These isotopes will always have the same properties, and this is because, sorry about that. So I was saying the isotopes will always have the same properties. This is because they've got the same number of protons, which is the same number of electrons, right? So the mass number of an element with isotopes becomes the weighted average of the masses of each of the isotopes, right? Let's have a look at the following examples. We have got chlorine isotopes. We have got chlorine 35 and chlorine 37. Chlorine 35 has got a mass of 35, mass number of 35, 17 protons and 18 neutrons. How did I get my neutrons? I simply said 35 minus 17 and I got 18 neutrons, right? And for chlorine 37, it has got a mass number of 37. We have 17 protons and 20 neutrons. How did I get my 20? I simply said 37 minus a 17, and then I got my 20 neutrons. So to calculate the average weight of your chlorine, you simply say 75%, because they gave us the abundances there. They told us that we've got 75% of chlorine 35 and 25% of chlorine 37. So 75% as a decimal is the same as 0.75. So you simply say 0.75 times your 35 plus 0.25 times your 37, and then you get the final mass of your chlorine, which will give us a 35.5 on this one. And then on our example, we are having oxygen isotopes. As for oxygen, we've got oxygen 16 and oxygen 18. Our oxygen have got 8 protons. So to calculate the number of neutrons, we simply say mass number minus the proton number. So 16 minus 8, we get 8 for the other one, and 18 minus 8, we get 10 neutrons for the other one. But then the abundance is now on Earth. We have got 99.8% of oxygen 16 and 0.2% of oxygen 18. So to calculate the average mass of these oxygen isotopes, we simply say 0.998. I just converted 99.8% to as a decimal. It becomes 0.998 times 16. That's a typing error there. We have 116 instead of a 16, plus 0.02 times 18, and then our average weight becomes 15.84 there. That's how we calculate the average mass of isotopes. So that's all for today.